your plates. For example, you have your project located in Manila, say very near TUP. So this is the snippet from NSCP. Again, we have two zones, Zone 4 and Zone 2 under NSCP 2015. And there's another page there where you will see the specific fault line near Metro Manila. So in this case, the Valley Fault System. And that page also has a symbol, no? A scale, wherein that measurement you can find this distance using the scale here. It turns out this is 10 kilometers from Valley Fault Line, fault system. So for example, your plate, say it's a 4-story. Okay, so say this is your project located in Manila. Okay, so your distance to the nearest fault line, or distance, is equal to 10 kilometer. And on our example project, the importance factor is 1.5 because this is a school, as you will see later. Then soil type, let's assume it's SD. Soil type, SD. Technically, this should be coming from, what happened? SD. What's happening? SD. Soil type SD. So this should be coming from the geotech, no? So there should be a soil report, geotech. Okay. When I was a geotech before, when we did the report, uh, we set this. Okay. Even the NA and NV parameters. Okay, next is, so I have here the other tables that you will need there. So as a geotech, normally they refer to this table. So what's the basis for SD, soil type? If the soil, if the N blows or SPT value ranges from 15 to 50 blows. So this is the depth this is the number of blows required to penetrate a 300 mm hammer to the soil. No? If your range is from 50 to 50, so this is quite large. No, the range, no, the range is quite large from 15 to 50. Therefore, you will observe most of the soil will qualify to SD. Most of the soil will qualify to SD. But in reality, some part of Manila, say even in Sampaloc, so some parts there has SPT value less than 15. So it may qualify to SE. Okay, so for now, let's just assume SD. Okay. SC, this soil type has greater than 50 blows. So portion of Novaliches and even Makati CBD. So those some portions there are SC. So almost rock. So hard soil. Next is to so you will need soil type here in getting the CACB. So before getting CACB, you need NA and NB. So where's the table for NA and B? So this is the table for NA and B. So as you notice, I compare here two tables from 2015 and 2010. So there's a difference between 2010 and 2015. So 2015 has now a 2 kilometer distance, while 2010 do not have the 2 kilometer column. So that means when your distance from the fault line is on a range of 2 kilometers, that means you will experience more ground shaking. It's now incorporated in 2015. So since we are 10 kilometers from fault line and our source type is A, the valley fault system, your NA is 1, okay? While your NV is 1.2. 10 kilometers, 1.2. So how do we know it's source type A? The definition is here. Okay, where's that? Where is source type A? I forgot. Maybe it's here. In 2010. 2010. So again, I have my own copy of 2015 or original from ASEP. So this is the definition of source type A. This one. So faults that are capable of producing large magnitude events have high rate of seismic activity or moment magnitude greater than 7. Remember the JICA study of West Valley Fault? It can generate about 7.2 magnitude. So that means we are qualified in source type A. Okay. So 1.5 as importance factor because we are in a no we can qualify the school as essential facilities. So let's qualify that as an essential facilities. For now, as our discretion, essential facilities because what's the definition? Uh, Structures and shelters in emergency preparedness centers. So in case there's an emergency, we can use the school as an emergency preparedness center. How about the definition of NSCP? Okay, nothing. Ito lang, essential facilities. Next is, so we now know NA and NB. So we can now determine CACB. So CACB. Since we now know soil type as SD. So that means we will be using 0.44 NA and 0.64 NB. We are under zone 4 or zero point 0.4 as PGA. Okay. What else? R value. Our R value is the response modification factor. We will be using moment resisting frame system. This one, oops, 8.5. Yeah. So you noticed For zone 4, uh, the intermediate moment frame 5.5 is what? NP, not allowed. 3.5, not permitted then, NP. Therefore, the default value, as I see it, no, most of the time, typical case, is 8.5. Okay? So, special moment frame because our lateral resisting system is purely girder and column. So, we call this moment frame. In case there will be shear wall, say you have shear wall, it's now a combination of moment frame, girder and column, plus the shear wall. So it's now dual system. So you are now in the dual system. So in our case, we are only using moment frame, girder and column, so that is 8.5. Okay, so at this stage, if you now plug in our formula, we now have the CACB, we now know the importance factor, we now know the R, 8.5, and we now, the weight is a different calculation as I will see later, as I will demonstrate. Okay, how about period? T. What's formula for T? Period. So by the way, no, R value, that is the factor that we use to reduce the base shear. No? As I always say, this is the elastic response spectra, and by incorporating R, 8.5, we are reducing the base shear that we apply to the structure, no? From elastic response to inelastic response. So that means you now should expect your structure to behave inelastically because you are using a reduced response spectra by incorporating the R value. Where is the formula for period? This one, I think. Yeah, this one. So we will be using a structure period method A. So CTH raised to 3/4. So CT is 0.0731 for RC moment frame. Okay? And height is the height of the building. Okay? So just find this height. And raised to 3/4, you will now be able to find period. Take note, you have two methods to determine the period. Method A is this one. Okay? While method 2 is this, or method B, this one. Now by now, I guess you should now be familiar to the formula 2 pi square root of m over k. Okay, so this formula is actually this. I have a video discussing the similarity of these two, no? Or the equivalence of that two. Okay, so you now know, we now have those parameters. We can now find the base shear. So applying this formula, this is the total design base shear, but the code says you should not exceed this value, 2.5 CAIW over R, and you should not be less than this. And in addition, for zone 4 located project, you should use this. You should also use this, compare with the 3. Okay, so these are your 4 formulas of design base shear. Okay, and uh, take a look. I want you to recall the response spectra here. So remember 2.5 and CVI, right? 2.5 and CVI. So, okay, this one. So, let's go back to the response spectra. As you notice, we again have this one, 2.5 Ca, right? While CVI over RTW is this, okay? So, what does it mean? So, the Vmax is here, and which is 2.5 Ca. Just add I over R. This is now your Vmax for inelastic response spectra. And for CVI over RTW, add multiply to I over R, nandito ka na. Okay? So just to appreciate the formula and the response spectra curve. As a heads up, no, in most low-rise structure, what governs is this, 2.5 CAIW over R. So that means if your period is somewhere here in this range, of course, if you are stiff structure, low-rise, you have period, very low period. So you are in this zone here. So I highlight. Ayaw. Okay. You are in this zone. For mid-rise to high-rise, you are in this zone. Okay? Okay, so now you know those formulas. Let's proceed with our project, sample project. Okay, so ito yung project natin, no? Okay, so assuming na okay na kayo sa mga formulas, so how do you find the weight per floor? Okay, so the idea is kailangan nyo lang kunin yung weight per floor. So we have a sample calculation here. Very manual lang, no? Kasi ito rin naman yung gagawin nyo, manual calculation. So for example, ano yung mga dead load ng structure? So per floor, you have the column, you have the beam, yung slab, yung stairs, yung mga exterior and interior wall, yung floor finish, yung ceiling, electromechanical, kung ano pa, no? Okay. Also, meron tayong interior partition na, no? Which is 1 kilopascal. I-add nyo yan, no? 1 kilopascal. Oops. So, okay. Interior partition. Okay, 1 kPa. Yan. So, basically, kunin nyo lang yung pansinin nyo yung formula, no? 24 kilonewton per cubic meter. Okay, that is unit weight ng concrete. Then, multiply mo lang sa cross-section niya. Cross-section ng column. Okay, cross-section. Then, yung length. Litan ko yung pen. Oops. Hindi pa rin. Yeah. Sige, then length of the column, then how many pieces. Okay, so you will get the weight. Basically, unit weight times the volume lang naman, no? For the beam, ganun din, no? Cross section, kung ilang piraso, pieces, then ganun din cross section times yung haba times dun sa unit weight of concrete. For slab, slab is 2.4 kPa because that is basically 100 mm. Let's say this is this is your slab. ang thickness mo is 100 mm, tapos meron kang 24 kilonewton per cubic, 'di ba? So 24 kilonewton per cubic meter times 0.1. So that is 2.4 kilonewton per square meter or kilopascal. So kaya 2.4 kilopascal yan. So may kilopascal ka na, multiply mo lang sa area, no? Kaya meron kang area times yung ilang piraso ng slab, and that's it. Meron ka ng weight. For the stairs, parang slab lang din naman yan, no? Assume ka lang nung thickness ng stair mo, and then yung length, okay? Okay, and then kung ilang piraso, so you have the weight. For the wall, to get the wall, specifically the exterior wall, no? So this is CHB kasi, no? We have a table here, dead load. Sorry, where is NSCP? Sign criteria. Yan. So ito yung meron tayo sa NSCP, yung saying meron kang CMU or CHB, tapos assume ka ng this density, tapos full grout. So you have 2.5 kPa, di ba? 2.5 kPa. Teka, wala yung zoom it ko. Okay, so zoom it. Yan, no? So assume tayo full grout yung CHB natin, say 100 mm thick, 2.5 siya. Then sabi ni code, add ka ng 2.4 kilopascal each face. So 2.5 plus 0.24 times 2. So ilan yan? So that is 2.98 kPa. 2.98 kPa. So yan yung exterior wall in kPa, no? So balik tayo dito. Kaya papansinin nyo almost 3 kPa siya, no? So assuming 3 kPa yan or 3.3 kPa, multiply mo ngayon yan sa height of your exterior wall. Tapos di ba, say 3 kPa times height or in meter. So that will be 3 kilonewton, per meter, square meter times meter. Cancel out to. Ayan. Then height is typically 2.8 or 3 meters, di ba? Yan. So you will have 3 times 2.8. So 8.4 kilonewton per meter. So parang yun ang lalabas na 8.4 kilonewton per meter. Yan. Na uniform load ng CHB. If 2.8 meter yung height mo. Okay, so it depends sa plano nyo, no? Ayun, so basically parang ganito yun, no? Then multiply mo sa haba, sa length nung CHB mo. So you will get the weight. Okay, for the floor finish, yan, typical naman yan, 0.77 kPa times the area. Have this, ceiling. So check nyo na lang sa sa design criteria nyo, no? We have, so yung dead load dito. Ito yung mga typical values Check. So hindi naman kasi to RCD or TOS to design. I am concerned more on sa sa earthquake force. So dito kayo makakuha ng mga dead load materials or values. So for example, ceilings nandyan. Ayan. Floor finish, ito 1.10 kapag ceramic tiles on a 25 mm mortar bed. Dyan. Ceiling, electromech, nandito din. No? Yan, nandyan yung mga yan. Else, yung mga roofing, nandito din. Okay? So, ito yung CHB kanina. Or CMU. Okay. Okay, so, ayan, nandito yung electromech and ceiling. And then, wag nyo rin kalimutan yung interior partition na 1 kPa times the area. Because, andito yan sa NSCP. Yan. So, partition loads. Under siya ng dead loads. Okay? Sabi niya, floors in office buildings and other buildings where partition locations are subject to change. So, equal to 1 kPa. Kung office building, no? Yan. Okay. Okay, so that's it. So, sum up nyo lang yun, meron na kayong weight per floor. Okay? So, now, once you now know the weight, so, ma-apply nyo na yung, yung Bayesian formula. So, sa ating project, sa sample project ko dito, I got this, weight per floor, 1,053 sa roof, 7,816 sa fourth floor, third floor, and then second floor. Total weight of 8,870 kilonewton. Okay, then, ang meron na computation dito, this one. So, yung pinakita kong formulas kanina, na-apply na niya dito. Yan. So, okay, where's that? Oops. Yeah. So, applying those formulas, Vmin is this one. Vmax is this. Yung actual base shear is this. And additional formula na for zone 4 is this. Yeah. So, what governs? I think na-overlook lang ito dati. So, what governs is Vmax. No? Because your actual base shear is 2,136. Okay? But sabi ni code, you should not exceed the Vmax, which is 1,721 lang. Okay? So, na-exceed niya no? So, therefore, this governs. Okay? So, governs. Okay. So, Vmax. So, what? Remember, I told you na in most cases, sa low-rise, itong nag-govern. The Vmax. Okay? So, once meron na kayong base shear, 1,721. Where's that? Okay. Okay, so since Vmax governs, so 1721.82, i-distribute na natin yan vertically sa building natin, no? So, ito yung tabulation which you will do sa plates. So, tabulate nyo yung weight per floor. Okay, ilagay na siya dito. Then, yung height niya from the ground. So, 12.2, 9.2, 6.2, 3.2. Okay. Then, multiply nyo itong dalawa. Weight times h. So, this one. You get this. Multiply nyo sila. And find the summation of this. So, you have this. And just simply divide mo lang per item. This one over this. So, you have this. Okay, this one over this. You have this. This one over this. This one. This one over this is this. Okay, then ilagay nyo yung nakuha natin base shear na 1721.82 and multiply nyo lang sa kanila. Sa kanya, no? So, 1721.82 times 0.08, I got, oops, na-move yung no? Wait lang. Okay, so ito yung lalabas na force per floor. 0.08 times 1721.82 is 137.75. Yan. Then 0.45 times 1721.82 is 774.82. So 774.82. Then sa third floor, 0.31 times 1721.82, 533.76. And lastly, 0.16 times 1721.82 is 275.49. So, pag sinama mo to, of course, ang lalabas yung base shear. So, ito lang yung distribution per floor. Okay. So, distribution per floor, yan. So, you can imagine that as is our building. Okay. So, we're saying that yung 1721.82 na base shear will be distributed vertically per floor. No? So, sa roof, we have 137.75. 137.75. Sa fourth, we have 774.82. Sa third, 533.76. And then sa second floor, 275.49. Okay? Yeah. But remember, per ano yan, per floor. So, kailangan mo pa siyang ma-distribute horizontally sa frame. Yan. So, let's focus first sa 137.75. So, ito siya. I-distribute natin yung 137.75 sa fourth floor. Okay. So, ito naman yung computation nun. So, nilagyan ko na lang ng correction dun sa may nagsabit na plates before. Yan, okay. Okay. So, ilalatag nyo yung frames na kung saan naka-apply yung force. Yan. So, we assume na dito siya nag-act, no? Sa direction na to. Okay, dito siya nag-act. Well, dito siya nag-act for now, no? Pero, ang earthquake is cyclic, so pwede siyang mag-act dito sa Z direction. So, or north to south, ito yung east to west, no? Ito yung north to south, then cyclic yan, no? Pwede rin sa kabila. So, for your plates, assume muna tayo dito. You will do both direction, ha? For this discussion, assume lang ako ng east to west. Now, sino magre-resist ng base shear sa east to west? Itong tatlong frame. Frame A, frame B, saka frame C. Right? Kaya ilalagay nyo siya dito. Frame A, frame B, frame C. Okay. And then Y3. No? This is an arbitrary value because yung cross-section ng columns are all equal. No? So, okay to. So, let's assume 3. Okay. And of course, tatlo yung frame. So, ibig sabihin yung stiffness per frame is arbitrarily 3. So, this is true if in case na yung sizes ng columns, no, are all equal. No? And yung configuration ng frames are the same. Yan. Okay? And as you notice, no, sa plan-wise, symmetrical naman kasi yung plano. Yan, no? So, yung quantity ng column per frame, sa frame A, halimbawa, 1, 2, 3, 4, 5, 6, 6. Sa frame B, 1, 2, 3, 4, 5, 6, 6 din. Sa frame C, 1, 2, 3, 4, 5, 6. So, they are all equal. Tapos, equal pa yung cross-section. The assumption is equal. So, equal din yung stiffness nila. Okay. Next is, so after that, kukunin mo yung summation of k. Siyempre, 3 times 3 is 9. Then, kunin mo yung uh, ratio. No? So, since equal naman sila lahat, no? So, of course, 1/3 yung hatian. No? So, k over summation of k, 0.33. Yeah. And then, lagay mo yung force na i-distribute natin, which is 137.75. Okay? Yan. So, 1/3 of 137.75 is 45.92. Okay? 45.92, 45.92. So, that means, basically, hinati natin into 3 yung 137.75. Yan. No? So, ito yung tinatawag nating direct shear. Yan yung direct shear natin. So, meron tayong mga solved problems niyan. No? Sa uploaded niyan sa ating channel. Yan. So that is the shear the direct shear per frame sa roof floor. Then if you repeat the same process para sa right now ang dinisibid ko is 137.75, no. Pag ni-repeat niyo yung process na yan, so fourth floor yon, roof floor, sorry. Basically, hatiin mo din itong 774.82, itong 533.76, 275.49, yung nasa second floor, you will get this. Yan. Okay, yeah. So, from roof hanggang second floor. So, yan yung horizontal distribution ng ating base shear sa east-west direction. Okay? Okay, but we know that the code requires, no, na mayroon tayong accidental torsion. No, sabi ni code, kahit pa regular yung frame mo, assume ka ng 5% eccentricity. So, sabihin, we will have a torsion, no, from the 5% eccentricity. So, ito naman yung computation nun. Okay. So, ito naman. So, sabi niya, eccentricity is 0.05 of the span. No? Actually, least horizontal dimension yun. For the plates, so assume tayo ng 0.05 of the span. Which is, ang ating haba dito is 9.5 to. No? Yung distance nito. Kasi this is 7, while this is 2.5. So, 9.5. 9.5 divide 2 is 4.75. Yan. So, ito siya. So, natin nasa gitna yung ating center. Yan. Center of mass and even center of rigidity. No? Assume natin, no? 4.75. Pero sabi nga ni code, assume ka ng 0.05 na eccentricity. So, 0.05 times 9.5 is, you will get, where's that? Yan, 0.48 meters. So, yan yung eccentricity natin. 0.48 meters. So, having the force 137.75 sa fourth floor to, no? Multiply sa eccentricity na 0.48, you will get 66.12 kilonewton meter. So, yan yung ating torsion. Okay? So, assume natin na umangat tayo. Yan. So, 0.48. Angat tayo ng 0.48 meters from the center. Yan. So, 0.48 po to. So, this is the eccentricity 0.48. So, yung dating 4.75, naging 4.27 na lang yung distance dito sa frame A. Tapos, ito, itong frame B, naging distance na niya sa sa display center is 2.73. While itong frame C, ang distance na niya ay 5.23. Okay. So, meron tayong 66.12 kilonewton meter na torsion, no? So, assume natin na andito na yung force natin acting with the eccentricity here. So, ito na yung naging torsion natin kasi umikot, no? Pinaikot na niya, no? Yeah. So, with this torsion, kailangan may magre-resist. So, ang resistance niyan, if this is so, umikot ng paganon, if this is clockwise, so ang magre-resist dyan ay counterclockwise. So, para makaproduce ka ng counterclockwise resistance, yung direction ng resistance ng mga frame A, B, and C is this. Right? Yung frame A, may resistance na paganto. Si frame B, magre-resist to the right direction, and also frame C. Right? Para maging clockwise resistance. Okay. Next is ito na yung mahabang table niya. Okay. So, K is, alam niyo na to, no? How we get that. Plug in nyo yung mga distances. No? Remember, this is frame A, B, and C, no? So, dito yung natin, no? Yung center. So, si frame A lang yung negative, right? So, which is negative 4.27. So, ibig sabihin si frame B and frame C, positive. Okay? Kasi si frame A bumaba, no? While si frame B and C tumaas from the center. Then, you have the D. Multiply nyo yan, KD square. Of course, square nyo muna yung D before multiplying sa K. You have this. Yan. And then, find the summation of KD square 159.12. Yan. Then, parang ginawa nyo kanina sa horizontal distribution. KD square over summation of KD square. So, ito yun. 0.344, 0.14, 0.516. Then, alam na natin yung MT, 66.12. Divide natin sa D. So, 66.12 divided by negative 4.27, you have negative 15.48 to. Negative 15.48. Then, 66.12 divided by 2.73, you have 24.22. Then, 66.12 divided by 5.23, you have 12.64. Ito yun. 12.64. So, yung fj double prime x is simply multiply mo lang itong dalawa. Yung column na yan. Yan. So, 0.344 times 15.48 is negative 5.33. Yan. 24.22 multiplied sa 0.14 is 3.4. And 12.64 multiplied sa 0.516 is 6.522. Okay? Then, mayroon kang column for fj prime x, yung kanina, yung 45.92. Yung sa direct shear, ayan yung direct shear. So, mapapansin nyo, yung negative lang na fj double prime x is yung si A. No, kasi siya lang yung di ba? Remember, siya lang yung going to the left. Si frame B going to the right, pati si frame C. So, additive sila. So, negative 5.33 plus 45.92. So, kunin nyo yung sagot dyan. And then, 3.4 plus 45.92, kunin nyo yung sagot, no? So, hindi ito, no? Then, lastly, 6.522 plus 45.92, kunin nyo yung sagot. So, it turns out, ito yung lalabas. So, this one is yung sagot dito. This one is yung nandito. While this one is here. So, syempre, pag supposedly, pag sinamap nyo tong tatlo, you will still come up with this, dapat. So, meron lang round of, ano lang dito, no? Siguro round of discrepancy, no? Kaya hindi siya nag-match, no? Pero basically, almost the same, no? So, mapapansin nyo yung dating 45.92 dito, nabawasan sa frame A. Pero pagdating sa frame B and frame C, nadagdagan yung 45.92. Because, kasi nga, nagkaroon tayo ng torsion. Yung distribution nung shear force due to torsion is nagbago. Okay? So, yan. You will repeat the same process, no? Sa each level, no? Yan. Okay? So, you will repeat the same process. So, each floor. So, nakita nyo yung trend, no? Yung sa frame A na bawasan, no? Pero sa frame B and C nadagdagan. So, you can now imagine yung 258.27 mababawasan yan, no? Where's that? Diba, remember, sa fourth floor, ito yung distribution from direct shear. Ibig sabihin, due to torsion, mababawasan ito, madadagdagan itong dalawa. So, ganun din dito. Mababawasan to, madadagdagan tong dalawa. Okay? So on so forth, no? So magkakaroon kayo ng panibagong distribution ng shear from roof to second floor. And after doing that, no? Kukunin ko na ngayon yung So assume ako ng So, ito yung 40.59, nilagay ko na dito. Then, assume ako na yung 258.27 sa frame A, fourth floor, is now 220. Then, yung dating 177.92 sa third floor is naging 160. Then, lastly, sa second floor, yung dating 91.83 is naging, say, 85 kilonewton. So, yan na yung total lateral force acting sa frame A from our base shear. And yan na ngayon yung if-factor method nyo or portal method or cantilever method to get the shear and moment diagram. So, ang ginawa ko dito is basically portal method lang to, no? Sample lang, no? For example, yung 40.59, no? So, sa portal method, di ba? Twice yung shear sa interior column, di ba? So, for example, 40.59. So, equals, so assume natin na x yung nandito, x yung shear. So, 2x yung nandito sa interior. Yan. Kaya, 2x yung mga yan. So, how many interior yan? 1, 2, 3, 4. So, 1, 2, 3, 4. And then, dalawang x. So, dalawang single shear. So, you have 10x. So, basically, 40.59 divided by 10, ang magiging x mo is 4.06. So, ibig sabihin, yung shear dito is 4.06 sa exterior. Okay? 4.06. So, therefore, yung shear sa interior is times 2 of that. So, 8.12. Yeah. And by ano lang to, no? By equilibrium, makukuha nyo na yung per joint, no? Per joint, makukuha nyo na yung shear and axial. So, halimbawa, 4.06 to get the axial here, 40.59 minus 4.06, 36.53. Okay? Tapos to get, so this one, okay. Yan, the summation moment ka dito, no? So, for example, 4.06 times, kasi ang nito is 3.2 Tapos ito is 4.5 yung distance. So 4.06 times 1.6, nasa gitna nag-aakyan, no? Then ang kukontra itong axial na to, no? So is equal to, say that is y times anong distance? 2.25, half ng 4.5. So you will get 2.89. Okay? Yan. So basically kung magpo-portal method kayo, so parang ganito yung itsura, no? So ang una ko lang naman nakukuha agad is yung shear sa sa per floor. Then makukuha nyo na yung, of course, yung shear diagram agad kasi may shear ka eh. So for example, ang nakuha ko dito is 50.56. So ang shear ko dyan 50.56 yan, or 50.6. Ito yung shear ko. Tapos ang shear ko sa second floor is 42.06. So ito naman yon, 42.06. Third floor and fourth floor. Then for the moment, so moment later mo na makukuha yan kasi after mong matapos yung calculation per joint. So how do I get the moment sa say halimbawa dito sa girder? After getting yung na to, yan, 2.89 multiply mo sa distance which is 2.25, half ng 'di ba? 4.5. So 2.89 times 2.25, that is 6.5. 6.5. Okay. So ito yung moment sa ating girder. Okay. Then for the 48.2. How do I get 48.2? Medyo naghahang yung aking Saan makita nyo? Yan, yung nakuha ko kasing shear doon sa inflection point is 21.42. Yan, 21.42 times 2.25, 48.2. Okay? So, how about sa column? Sample tayo ng column. Moment sa column is yung shear mo, 4.06 times yung distance na to, half of the height. 1.6 yan, no? Kasi 3.2 yung natin, center floor to floor. 4.06 times 1.06 is 6.4. Then 26.06 times 1.6 is 41.6. Ayan. So ganun lang magkuha no. For the shear diagram naman ng girder, yun, 2.89 yung nakuha natin dito, di ba? Of course, 2.89 yun nandito. Yung magka-counter sa kanya. Of course, dahil this is going up, so yung shear mo dito is going down. Kaya ang shear diagram ko dito ay pababa. Okay, pababa. Okay, so that's it. So good luck sa inyong plates.